I really want to talk about protocols now and kind of what those are. When we send data back and forth on the web, we typically, up here, as you can see I have an HTTPS, right? And that's what we call the protocol. And a protocol might be HTTPS, we might have HTTP. In this case, it'll probably kick us back to HTTPS, it did. You can see it there. And even if you don't see them, as I click off, you can see it, that protocol kind of disappears. When I click back on, specifically into that area, you can see how it will appear. And pages do come across HTTP or the Hypertext Transfer Protocol or the Hypertext Transfer Protocol Secure. And think of it like almost like a language. You know, you both have to be speaking the same language to talk to one another in order to understand each other. And so there's a lot of protocols that are developed to talk online, you know, between each other, okay? And so the first one and the most commonly used is HTTP and HTTPS, and each of those. And HTTP is going to use a specific port, and we'll talk about those ports here in a second. But it's going to use HTTPS is going to use 443. And even though you don't see it when I hit enter and that disappeared, it is talking across on that port. And so if I take and I change that port to something like 200 or something like that, and I run that, it's going to come back with an error because it doesn't know what port to talk on. Now, let me pause that because that's going to keep going there for a little bit. If we rewind back to our diagram here, and we were punching through this firewall as we were talking back and forth. You know, as we go out, you kind of need to think of this firewall. I'll put a hinge right there, and I'm going to put a door right here. Think of it like a door that you can swing outwards, right? Rather than swing inwards. And so if you want to go out, you can just push that door open and come back through. And as you come back through, let's do another color here. And we're going to come out and go into the web, and we're going to come out of the web into this router. If this other firewall was not configured with an open door, you know, then we wouldn't be able to come into it and make those changes as we needed. And so on this, you know, firewall, I'm going to just draw a hole, and we'll just come out and we'll go back in that firewall, through the firewall, and the router into the server. And these holes in our firewall, we want to refer to those as ports. And each protocol has its own port. And I can kind of show some of those examples here. I have a list of port numbers of protocols with their ports. And if I go down to port 80, you can see here, nope, this is the wrong one. This is a list of IPs, protocols. Sorry, I pulled up the wrong one here. Here we go, of TCP ports. There, we see on port 80 that it's assigned to the HTTP or Hypertext Transfer Protocol, found right here. And if we go down to port 443, you can see that's put on HTTPS. There's a lot of other ports out there, and these ports go up to, I think, like 67,000 or some crazy number. There's a lot of them out there. You know, this list goes down to 49,000, or there's a 64,000, and a lot of different ports assigned around. And so I wanted to talk about some of those that are most common. So if you guys have ever had where you're setting up your mail, this is an old photo I found of an iPhone, and you had to set up your email address to make that work. Often Gmail, for example, if you're connecting Outlook, or sometimes a phone, if you have to manually add those, they will give you specific protocols to use. So you can see this is a POP protocol and also an SMTP protocol. And POP is used to go out and collect incoming email, and SMTP is used to send email out. And you can see in here that's giving the server to go look at. It's using the POP protocol. It's using encryption, and it's going across port 995. And our SMTP is going to look on this server, some authentication and encryption, and it's using port 587. And so, depending on what your protocol is, you'll have different things that come up. Okay, so I've got this graphic that I found here, and let me go over, actually, before I go into that. I have another protocol that we'll use. Well, before I move off of email protocols, there's another one called IMAP, and that one basically syncs your email. And we could probably find all those port numbers. IMAP is on here somewhere. There's 143, the port number assigned to it. And when we're pushing documents around, we can specify ports just by doing a colon, 443. And if the browser is using the protocol on the port number it's supposed to be using, it just hides that protocol number from it. But we can see on email settings, there's a bunch there. There's a one that we will be using this whole semester long, and this is called the file transfer protocol. And sometimes we'll use the secure file transfer protocol as well. And so we're going to be using port 21 and port 22 from time to time. And just like HTTP uses a browser to view and move data around, we need a specific application that can run that protocol. Our email clients also are a specific piece of software to run email protocols and those port numbers. And with this file transfer protocol, or FTP, we need to use specific software that can view that. And so in this class, and I have another video that will show more in depth on how to connect and make these connections, but understand that you need a URL that you're going to be visiting, right? A location of a server to log into. And you're going to need a username and a password, and also the port number to be using. And on it, it looks something like this. This is one on here that's really common and popular, WinSCP. You'll get a list of data on your computer. Just think of it like a file manager on your own computer. And then you'll also get a list of the files on the server. So the server has just a list of files, like your own file manager, and you can move files up to that. You can upload them and you can download them. And then using HTTP, you could go through and specify that you want to view that specific file. So WinSCP is great, CyberDuck's great. You'll see me use that from time to time. Transmit, FreeFTP, FileZilla is wonderful. There's a bunch of them. I'd probably stick to WinSCP if you're on a Windows machine, and maybe CyberDuck if you're on a Mac. And I'll probably be using CyberDuck on and off, and so you'll see that in future videos. Now we have something called the Transmission Control Protocol / the Internet Protocol, and we call that the TCP/IP. Okay, and it is really the way we go about communicating amongst all the servers and sending data back and forth. And when we're talking back and forth from these computers, it doesn't send the data in one solid chunk. It sends it in little itty bitty little chunks. And you can see on these dashed lines, they're dashed for a reason, because every dash, as you see going back and forth on there, think of it like a little section of the data, maybe 1% of the data, and probably significantly less than that. And so you're machine gunning, this data back and forth from all these computers. And each one of these little dashes and each one of these itty bitty little types of data are what are known as packets, okay? And this is kind of what a packet looks like on the inside. It talks about, there's a bunch of different data here, and let's talk about a few of these that might make sense to you. Let's talk about first the source address, and this is where it's coming from. If I'm going to send a letter in the mail, I need to put a return address on that, right? And I also need to send where it's going. So if I'm going to send data from my computer over here out to that server, I'm going to send it, and it's going to hit this modem. This modem's going to look at that letter, and it's going to say, oh, I need to send this out to this domain name, and it's going to somehow go out on the internet and out to some server, and that server is going to look at it and say, oh, I have a request for this cat picture or something, cat video, and I need to return that cat video. Where do I send it? Well, I'm going to look at the source address on those packets that were sent to me, and I'm going to send that back. And so it's going to put a destination and kind of reverse the destination and the source, and send that video back. Now that video is going to come in itty bitty little sections, right? It's going to come in little chunks. And so if, let's say we broke that into 100 different pieces, we want to make sure that every piece of that cat video gets over, right? And we're going to say, instead of our header checksum data, we're going to say expect 100 packets. And if you miss one, this is the one you should be looking for, essentially. And so if we return that cat video and it doesn't all the way get there, then we just make a request back to the source where that came from to say, hey, we need this one little section of the cat video sent back to us. And that's what this checksum data is, just to check. You can see in here we've got a protocol and how long you should be trying before you give up, and the length of the packet and the type of service and the version of packet. And all this is controlled by the TCP/IP protocol that we talked about earlier. And again, that's how we move things around. Now, each computer online has a home address, okay? So again, think here, you've got all these computers here, and they're going through this router and out to the internet and back out to the server. Every mobile phone, every Xbox that's connected to online, and everything for the most part is going to have what's called an IP address. And think of it like a house address, so we know where to send these packets to, right? Well, these packets, we have two different kinds. We have what's called the Internet Protocol version 4, and that was developed when the internet was started being put together back in 1981. And you can see we have Internet Protocol version 6. And for the most part, most computers still, well, a lot of servers will still use IPv4. So if I take this and I ping google.com, for example, you can see how I have this IP address that is returned, this 172.217.13.78. And if I go out and I put that in here into my browser, you can see it actually pulled up Google directly and is loading it right there. And so you can go out and type in an IP address into your server here. So I could type that in, and I could say something like, we want to look at https:// and we want to look at port 443, like so. And it understands all of that when we're typing that data in. So IPv4 is what we use for a really long time. The problem is if we look at 2 to the 32ths, that's going to give us 4 billion addresses. And with everybody jumping on mobile devices nowadays and things like that, we are running out of addresses. And your ISP, who you get your internet from, will assign you that. And then if you really want to get into the details of this, your router will also assign internal IP addresses to all of your other computers to sit behind that one IP address. Not always the case. Sometimes your routers are set up to set individual IPs to each computer as well, but it does do that. And so IPv6 is much longer. You can see instead of, well, before I get into this, we have this number 192.149.252.76, all right? And if I type in this, it really comes in a set of 3 numbers, and each one of those numbers is going to represent a number between 0 and 255, and that gives us 256 addresses total in each one of these numbers. So a valid IP could look something like 1.145.56.0, and that would be a valid IPv4 IP address. And we could type that in. It might go somewhere. I don't know where that would go or who owns that IP address. But that's how that works. And so when we're looking at IPv6, it's much longer. Okay, we're using alphanumeric characters, and it's in multiple sections in here. 1, 2, 3, 4, 5, 6, 7, 8. And if we look at that, you can see how many addresses we have available, and we're not running out of those anytime soon. But as we saw a lot of third world countries come online, we did start running out, and it was kind of an issue. So that's what an IP address is. Think of it like a home address to a computer somewhere on the internet that people can get to. The other thing I wanted to talk about briefly was the DNS system, or domain name system. And so let me pull this off here. Well, let me actually keep that on and make some changes here. We don't always know, if we have an IP address, and I'm going to point that over to, or I'm going to say, sorry, google.com is going to point to this IP address. And we actually looked that up a second ago. I don't remember what that is off the top of my head now. It's right there. We could actually type that in. 103 dot, oops, sorry. 172.217. Let's do that really quick. So 172.217.13.78. Okay. Now, when you go to your browser and you type in an IP address like we did before, and that would take us directly to Google, right? Well, your computer does not have all the IP addresses stored in it for every domain name online. And so when you make a call out for a website, you go out in your switch and your router, out your firewall into the internet, and before it gets to your router, it actually goes over to something called domain name server. And that domain name server takes and converts that name into an address. And then it takes and feeds that address back, and it goes back into your computer, okay, back over to here. And then your computer basically puts in that address and goes out and knows that 172.217.13.78 is this server over here. Then it goes out, gets that cat video, goes back in your computer and serves that up. And it does it real time. And so you can always go out and look for domain names and see what they are. You could go out and look at something like maybe network tools. Oops. And this will, allow you to ping or look up, if we look up Google right here, it will even look up the DNS records for it. So it has, 4 DNS servers that are constantly repeating that back. You can see on that DNS server, it's saying take google.com and change it into this IP address here. And they have multiple IP addresses for it. And it looks at other stuff too. It says if you want to know what the domain names for google.com is, the domain server, look at that, and then that, if you ping that, will change into another one. You can see its email servers here that it's using for google.com and a bunch of other stuff. So this is just again a tool you can use online if you're not comfortable with the terminal. The last thing I want to talk about is we use HTTP to move data back and forth, but there's a new version of HTTP 2 that came out a few years back. And you can see here right now 79%, according to this graphic when it came out, we're supporting that. I know we've moved a lot farther than these versions since then. But HTTP 2, the way it works is, I've got a good graphic here. HTTP 1, if we had so much HTML, CSS, and different things we had to download every time we pulled a web page, it would take this much time because it would download the HTML, the CSS, different images, and so forth. With HTTP 2 now, we can do multiplexing, where we can download the HTML. The HTML will pull the CSS, some other HTML, and images with it. And so we can pull multiple feeds at one time rather than having to work you know, wait, I guess you could say, for all that to come through. So again, it speeds things way up. Now, most people are completely unaware of the change. It's really a change on the server. Again, the server is that specialized software we have running on those machines right here. And again, you could run this on your own server. A common piece of software that runs web servers is Apache web server. And you can look at that and install. And there's lots of FTP servers and email servers, and there's all these different servers that sit on your computer to do this. So domain name servers are what, you know, translate those back and forth, and the servers send that, and we have port numbers, and the group that controls what protocols are being made and what port numbers are assigned to those and what domain names are being set up. And a lot of this infrastructure is ICANN. We talked about that in a previous video, but they're the ones that are going to assign all of that data out to the world to use.